Hello, my name is Nadia Lim, and today we're going to be going over an explanation for question 1 from workshop number 2 in the Intermolecular Forces chapter. In this question, we'll be looking at the relationship between vapor pressure and temperature. So this is the question. When appropriately plotted, vapor pressure and temperature data for a particular compound yield a straight line with equation y equals negative 4,288.9 x plus 18.808. What are the values of heat of vaporization, vapor pressure, and beta for this compound at exactly 25 degrees Celsius? Each of your answers should contain 4 significant figures. Okay, so to start, we are going to remember the slope-intercept form for the equation to relate vapor pressure, heat of vaporization, temperature, and beta. So the equation is ln of vapor pressure equals negative delta H over R times 1 over T plus ln beta. And so just to relate it to the classic y equals mx plus b slope-intercept equation, the ln of p vapor is going to be our y value, negative delta H over R is going to be our m value, and 1 over t is going to be our x value, and ln of beta is our b value. And now, just to relate the slope-intercept equation to the equation that we were just given in the original question, our y value is y, our m value is negative 4,288.9, and our x value is x, and our b value is 18.808. All right. So now to start, we're first going to find the heat of vaporization, or delta H, as it's written in the equation. So remember from our slope-intercept equation, negative delta H over R is our m value, and negative 4,288.9 is our m value from the original equation in the question. So we can go ahead and put those equal to each other. Next, we will solve for negative delta H, and to do that, we just multiply negative 4,288.9 by our R value, which is 8.314 joules per K times moles. And because we want delta H in kilojoules, we're going to also multiply everything by 1 kilojoule over 1,000 joules, and that will give us a negative delta H value of negative 35.66 kilojoules per mole. Next, we're just going to multiply both sides by negative 1 and get our delta H value as 35.66 kilojoules per mole. All right, on to the next value, we're going to find beta. Similar to how we just solved for delta H, our b value in the slope-intercept equation is ln of beta, and we can go ahead and set that equal to the b value from the original equation, which is 18.808. And then to reverse the natural log, we're just going to go ahead and get beta by putting e to the e to the 18.808, and that will give us beta value of 1.473 times 10 to the 8. All right, and the last value that we're solving for is vapor pressure. So to find vapor pressure, this one is just a little bit more complicated because the vapor pressure in our slope-intercept equation is given as y equals ln p vapor pressure. However, in the equation given in the original question, we don't have a y value, so to get a y value, we are going to put in the temperature. So remember that our x value in our equation is 1 over T, which is temperature. So, and our temperature is 25 degrees Celsius. So we're just going to convert that to Kelvin, and that's 298.15 Kelvin. Then we're going to put 1 over T, or 1 over 298.15 into our equation to solve for y. And that will give us a y value of 4.4230. And then we can go ahead and set our calculated y value equal to ln of vapor pressure. And then the last step, we just reverse the natural log, set both sides e to the x, and then we will get a final vapor pressure value of 83.34 torr. Alright, so going back to our original equation just to make sure we have everything correct, we calculated the heat of vaporization as 35.66 kilojoules per mole, vapor pressure as 83.34 torr, and beta as 1.473 times 10 to the 8th. All right, thank you for listening.